So today we are going to do a lesson on unit rate as it pertains to slope. Now this is going to be a brand new topic that you may have not worked with before, but you're going to really be able to make some really solid connections to it. So in front of you right now there are two scenarios, and I would like to talk about them. So I have scenario one, in which somebody is driving over time, and this is the y-axis represents the distance in miles, and the x-axis represents the time that they traveled. You can notice that for every 1 mile, or 1 hour that they travel, they get 60 miles, and the point 160 is labeled here for you. So for 2 hours, they are going to travel 120 miles, 3 hours is 180 miles, and so on. Okay, that's the rate of speed that they are going, etc. And here we have scenario 2, in which y equals 55x. Now this is a linear equation. We're going to be talking a little bit about that. And so x represents the time in hours, and y represents the distance in miles. So if 55 is being multiplied every time they go 1 hour, so it would be 55 miles. If I substituted 1 hour in here, it would say, well, y is 55 times 1 hour. Then that would mean that y is 55 miles per 1 hour. So if they're going 55 miles for every 1 hour, that would mean that for 1 hour is 55 miles. Okay, so which scenario represents a greater speed? This scenario on the graph, in which 1 hour they've traveled 60 miles, so 60 miles per hour, or traveling for 1 hour and going 55 miles, which would be 55 miles per hour. The answer is scenario 1. And you can see here that I have labeled that our unit rate is the ratio of the x to the y, or the y to the x, in which one of the quantities is 1, right? And so our unit rate here is going to come in to be very important later. Okay. Here is a scenario I'd like you to think through with me. So at Dollar Tree, every item can be purchased for $1. So create a graph of the relationship between items purchased and total cost before tax is applied. So for every 1 item, you pay $1. So 1 item here costs $1. 2 items costs $2. 3 items costs $3. 4 items costs $4. And so on. And this relationship could go on forever. You could buy 1,000 items and it would cost $1,000. So I want you to notice that the cost that you will be charged, right, is going to depend on the number of items that you purchase. That means that the y value here, the cost, is the dependent variable. The number of items we purchase is completely independent. We could purchase 1, we could purchase 100, we could purchase 5. But no matter how many we decide to purchase, the cost depends on the number of items we buy. So the x value is going to be our independent variable, and the y value is going to be our dependent variable, because y depends on x, right? So if I were to look at this here, I know that for every 1 x, I get 1 y, right? Or I spend $1. So we can see here that y is going to equal 1 times x. So an x represents the number of items. So it's $1 per item, so 1 times x. And this 1x, because of the multiplicative identity, I don't need that 1 there. And so the linear equation for this situation is y equals x. If you could see this grid paper, as graph paper, you would notice that these points are on what we call lattice points, where the actual graph paper has an intersection. So this would be like this, right? Whoops, that was terrible. And then these go here. So the intersection on the graph paper, it's really easy to plot those points, because you can see that intersection. So with y equals x, that's always going to happen. It's very nice. All right. And our unit rate here, right, is 1 to 1. It's very cool because for every one item, it's $1. So our unit rate is the same for both situations. So that unit rate, you can see it in the equation as it relates to x. Okay? Here's another scenario. So at the concession stand for a basketball game, Gatorade costs $2. Write a linear equation to represent the total cost, y, of x Gatorades purchased. Then graph this linear relationship. So remember that the cost depends on the number of Gatorades purchased. So the total cost is going to be y, and the number of Gatorades is going to be x. So I'll just kind of put that there to remind me. Now, if I purchase one Gatorade, I pay $2. If I purchase 3 Gatorades, well, they're $2 each, so it's going to be 3 times 2 is going to be $6, right? If I purchase 8 Gatorades, maybe I'm purchasing for half the team, 8 Gatorades at $2 each, so 2 times 8, which in this case, x is 8, so 2 times x, right, is going to equal 16, and 16 is y. So we can see these points here. So what we notice is that y, the cost, equals 2 times the number of Gatorades because they're $2 each, right? So I can say, well, if I buy 1 Gatorade, it's $2. If I buy 2 Gatorades, it's $4. If I buy 3 Gatorades, it's $6. 4 is $8. And what do you notice? This linear relationship goes just like that. That's what the graph looks like for this scenario. If I wanted to purchase 8 Gatorades, if you were to follow this line all the way up, it would end up way up here. Okay, and you can't even see it. So you will notice that the slope of this graph is rather steep, right? That's exactly right. So what's the unit rate here? Well, 1 Gatorade is $2. So you could say, well, that's the 0.12. That would be good. 1 Gatorade to 2. How about if I wanted to know how many Gatorades cost $1? Well, if 1 Gatorade costs $2, then $1 would purchase how many Gatorades? Half of a Gatorade? Interesting to think about. I mean, it's not really something that's possible, but maybe if you and a friend were going to split a Gatorade, you would each pay $1 and then you would each get half, right? Okay. Here's another scenario to think about. For every lemon used in Miss Fox's famous lemonade recipe, she uses half a cup of water. Represent this relationship with a linear equation. So we're thinking the number of lemons she has, because maybe you have a certain number of lemons, I don't know, is going to depend on, the number of cups of water she uses is going to depend on how many lemons she has. She can only make as much lemonade as the number of lemons she has. She's always going to have enough water, but we can only use the amount of water that goes with the number of lemons that she has. So if she has 1 lemon, okay, if she has 1 lemon, then she's going to use half a cup of water. So if she has 2 lemons, then she could use a full cup of water. If she had 4 lemons, she would use 2 cups of water. If she had 8 lemons, think about it, half a cup of water per lemon, that's going to be 4. So what we're doing is we're saying, well, how are we getting multiplicatively from x to y here every single time? You'll notice the relationship. Multiplicatively, x times 1/2 is going to be y, right? So y will equal 1/2 times x, right? It also can be seen here in this table as a unit rate. The table is not something you have to create. It's just a good way to think about the relationship. It's a proportional relationship as well. And so here is what the graph would look like. For every 1 lemon, we have a half cup, and we kind of have the 1/2 point here of water. 2 lemons is a full cup of water. And notice that the steepness of this graph is much lower than that of the Gatorade example, right? And notice that the constant of proportionality here, the relationship, what's being multiplied by x, is much smaller than 2. I bet that that relationship probably makes sense once we get going here. Okay, the unit rate for every 1 lemon, it's 1/2 cup of water, or for every 1 cup of water, it is 2 lemons. So those are both unit rates to think about. So this is just one thing I want you to notice before we conclude this lesson. We had the graph y equals x, which is y equals 1x. And that hit all whole number lattice points. We talked about that. The example where we had y equals 1/2 x, that was just the previous one with the lemonade. That is a much shallower linear graph. It's a shallower line on the graph here. And that is under the y equals x line, right? If the y equals x line is here, if I graphed that there, notice this is underneath it. The y equals 2x graph, where we had the Gatorades, $2 per Gatorade, this is a steeper graph. And so that is the y equal, or excuse me, it is above the y equals x line on a graph. And so this number right here that's being multiplied by x in order to determine the y value, that is called our slope. It's our constant of proportionality. It's how much per x. Sometimes that's a large number, sometimes that's a small number. Either way, we're going to be using this format, y equals mx, and that m represents the amount of change per every x. So from now on, we're going to be talking about this number multiplying by x as the slope. Okay?